Hello, Gen Chem students. We're going to take a closer look at the effective temperature on delta G and therefore spontaneity. The equation is delta G equals delta H minus T delta S. As a reminder, when delta G is greater than 0, our process is non-spontaneous. When delta G equals 0, it's at equilibrium. And when delta G is less than 0, that's when the process can be spontaneous, when it can travel downhill. Delta H is the enthalpy term. This is usually just defined in terms of bonds being broken or bonds being formed, or heat that has to go in and out of the system to affect a phase transition, for instance, a solid melting into a liquid. This is independent of temperature. Entropy, on the other hand, you note that it's multiplied by temperature. That's because the entropy term is made stronger or weaker based on the temperature. And this makes sense because entropy itself is very closely related to the temperature of the system. Hot water has greater entropy than cold, for example, because the intermolecular motion of the molecules is much higher in a hotter system. Let's consider enthalpy versus reaction progress as we did the entropy gains or entropy losses. In an endothermic process, we're moving from lower enthalpy reactants to higher enthalpy products. This positive delta H means that energy is going in, that's an uphill process, but a sufficiently large entropy gain could offset that for a negative delta G. On the other hand, if we move from high enthalpy reactants to low enthalpy products, that's a negative delta H, an exothermic process. Energy comes out a downhill motion, but a sufficiently large entropy loss could eat that up for a positive delta G overall. Let's try another way of visualizing this. Here I have a number line. On the left-hand side, we're in non-spontaneous territory of delta G. In the middle, delta G equals 0, and we're at equilibrium. And then at the right-hand side, delta G's are less than 0, and therefore we're in spontaneous territory. If we have a negative delta H, this is already favorable, and we add on to that an entropy gain, so a positive delta S term, this will make that T delta S term negative at all times. You have a negative minus another negative, meaning that this is going to be spontaneous at all temperatures. The flip side of that, if we start with a positive delta H, this is already a slightly unfavorable process. We're trying to put energy into the system. If we pair that with a negative delta S and entropy loss, that T delta S term will be positive, we'll add on to the positive delta H, and we'll just keep moving further and further into non-spontaneous territory regardless of temperature. Processes with a positive delta H and a negative delta S are never spontaneous. But what about when you have these two offsetting each other? Well, this is where you get a tug of war depending on temperature. Let's start with a negative delta H. So we're starting from a position of favorability and spontaneity, but we have a negative delta S term that's going to offset that. How is this going to change with temperature? If temperature is small, we're at low temperature, then that T delta S term is also going to be small. It will only partially offset that negative delta H, but not enough to push it out of the territory of spontaneity. If, on the other hand, the temperature is very high, then your T delta S term is very large. That overwhelms that negative delta H and pushes us into non-spontaneous territory. Let's look at the flip side, where we have a positive delta H, which is beginning from a position of non-spontaneity, but we have a positive delta S, which would push us towards spontaneous. If temperatures are low, then we have a small T delta S term, and we aren't quite able to push into spontaneous territory. If, on the other hand, our temperature is very high, the T delta S term is large, overwhelms the unfavorability of that positive delta H, and pushes us into spontaneous negative delta G territory. If you need to see these for yourself, just take delta G equals delta H minus T delta S, and just imagine that you're plugging in, say, +1 or -1 for delta H and delta S, and see what happens as you put different values of T in there. I hope that this cleared things up. I will see you guys on Monday.